My name is Oleg Zhurakousky, and I will be talking to you about Apache NiFi, what it is, what it is used for, how to use it, and how to integrate it with Spring, and why would you do it in the first place. So before I do that, quickly about myself. I work for Hortonworks in the engineering team. Right now, primarily focusing on developing and promoting Apache NiFi. Prior to Hortonworks, I was member of this great Spring team, working on Spring Integration, Spring Scala, Spring Integration Scala DSL, and a variety of other projects. So still a big fan of Spring and some of the, most of the technologies that it provides. And we have a lot of clients right now that are using both NiFi and Spring, and they've expressed concerns that they want to be able to integrate the two in a kind of a simple and clever way. And we've done that, and essentially that work served as the idea for this presentation. So let's begin. Here's our agenda. We're going to go through some theory, talk about key concepts, and then I'm going to get into the demo part where I will show you some of the basics of the NiFi, touching on some of the internal features of NiFi, and eventually progressing into showing the integration points within Apache NiFi and how we also use Spring within NiFi for other development purposes. So to begin, I kind of want to start with this slide saying that, in a typical data processing paradigm, this is what it kind of looks like. You acquire data somehow, you throw it into some type of a data flow, some type of data processing environment, and then you persist it somewhere else. So that's kind of what we've been doing for the past, I don't know how many years or decades. But the reality of the world today is pretty much didn't change, but it multiplied. So now we have data flows, data processing, and going through a variety of geographical areas, variety of data centers and nodes, machines, and so on and so forth. So this slide kind of describes the modern data processing concerns. Like I said, multiple data sources of data, multiple sources of data, geo-distribution, multiple protocols for data transport. So we can't really rely on that we're only going to be talking in HTTP, or we're only going to be talking, messaging like JMS or Kafka. We have to be able to support multiple in a kind of a cohesive way. And then we have new technologies and products. So we can't really, we have to stay up to date and provide not only the first-class ways of integrating with those products, but also a framework-like approach where you as a developer can actually develop something to integrate with some of the proprietary products that you may have. Because the idea here is that just like with whether you're using Spring Integration or whether you're using Apache NiFi or whether you're using any other sort of a pipes and filters technology, the idea here is that, yes, we can provide first-class adapters and connectors to open source public systems like, like messaging, like Kafka, like things of that nature. But there's other systems within your environment that you may want to integrate, but they're proprietary. We don't know about them. So we need to be able to address both things, which is, well, in this particular case, primarily give you a development framework that will allow you to integrate with those technologies. So, and then we have many different new and some old, some new data processing paradigm, like streaming, event sourcing, and so on. So, and then security encryption, and one of my favorite is the new types of users. So, Spring is a developer framework, and primarily targets the developers, basically the guys and the girls with hands on the keyboard. Where now, when it comes to modern data processing paradigms, we have the new types of users who are maybe less technical, but they want to be able to, but they clearly understand the domain model of their business, and they want to be able to create these data flows and they need to have some tool to do that, which doesn't require setting up a meeting with the IT organization to develop something. So we need to be able to accommodate those users. So, and this is pretty much all the sort of requirements that started NiFi. Now, quickly stepping back, NiFi was started as a project within the NSA, and I believe back in 2006. And then the guys eventually got permission from NSA to open source it, and they started the company called Anyara, and then Hortonworks acquired Anyara last year, and this is how we ended up with Apache NiFi. That's kind of like a brief history. So modern data, one of the key concepts that I wanted to take out of this slide is that modern applications are no longer data-centric, they're actually data source-centric, because, we need to be able to pull the data from a variety of data sources. Sorry, I had a little blackout there. So we need to pull the data from a variety of data sources, yet represent it in a kind of a canonical way. So, and this kind of slide summarizes that what NiFi really is. So it's a technology that provides the ability to consolidate heterogeneous sources of data into one cohesive data flow while addressing concerns that we described, that I described earlier. So product or framework. So again, when you working with a lot of Spring technologies, primarily everything within Spring is going to be kind of called a framework, because it's, again, the target audience here is primarily the developers whose job Spring wants to simplify, right? So NiFi addresses that need as well. However, NiFi is also a product, right? Because, like I said, it helps those other types of users to not only design data flows, but also manage, monitor, change, and so on and so forth without getting IT organization involved. So it provides, which we'll see in a few minutes, it provides the IDE to design a data flow, and it provides, and that same IDE, that same UI, is used not only for the design, but also to control and manage the data flows. And it provides, it's based on like any kind of data flow would always be based on the very core architecture, which is pipes and filters, and a lot of the enterprise integration patterns. But what NiFi also does is there is another paradigm called data flow programming paradigm, and NiFi, and that defines additional concepts that you that needs to be addressed, and we'll touch on them shortly. So, so what NiFi provides on top of what pipes and filters, what you would expect from pipes and filters and enterprise integration patterns, NiFi also provides some of the data flow, or some of the data flow concepts as first-class citizens of the product. So those key concepts are managed flow of information, the data provenance, which is extremely important concept within a data flow, which is basically gives you an ability to always know where the data's been, what it looked like at any point of time. So essentially NiFi becomes kind of like right now there's a new buzzword called microservices, right? So what NiFi, and we'll see it in a few minutes, provides you is that every component within a NiFi, when it obviously defines the input for data and the output for data, and after each handoff, the data is actually persisted. So at any point of time, you can actually look at the state of the data that came into this component or came out of this component. And obviously, sometimes you can replay, sometimes you just want to look at the history for debugging purposes. So basically, there is never a loss of data. And you can, if something happened down the line, you can always restore it or revisit through the provenance and see what actually went wrong, and possibly resubmit and so on and so forth. So, and then there's security, obviously, as with any commercial product. So we provide that as well. So here's some of the key features. So I already mentioned guaranteed delivery. And another one is the data buffering. So yesterday I was talking about, I had a little presentation on live data streaming into Hadoop. And there is very interesting paradigms when it comes to the streaming data. So, I mean, the very simple one is capture, store, right? That's like the simplest one. But the reality is that that's not how we usually deal with data, because part of the problem with the capture store paradigm is that what if the storing part is not quick enough to accommodate the capture part? What's going to happen, right? So the typical paradigm is capture, buffer, process, persist. So now you need to have a little bit of a data buffering, and with the NiFi, aside from providing data buffering, we also provide the backpressure, which is the way to slow down the, for example, consumption of the data if your processors, your components are not able or not capable to keep up with the source of data, with the production of data. So prioritize queuing, flow-specific quality of service, data provenance, and many other things that you see on the slides. So from the framework perspective, so like I said, we provide a lot of out-of-the-box components for integrating with a variety of external systems, obviously JMS, AMQP, Kafka, and so on and so forth. But again, we can't provide everything and to fill every gap, because a lot of the things we simply don't know about, whether they're open source or whether they're proprietary. For those we definitely won't be able to know. So we expose the framework and extension points that would allow you as a developer to write your own components that will be running within NiFi and integrating with your proprietary systems. So flow-based programming paradigm exposed through API, extension model, where we have, as you'll learn in a few minutes, concepts like processors, controller services, reporting tasks, and so on and so forth. So those are something that you can extend and develop your own. And we obviously provide the API to do that. So here's some of the flow-based programming key concepts. So information packet. Within NiFi, it's the called flow file. And for those of you who are familiar with messaging in general, flow file is basically a message. It contains the content and it contains the attributes, right? So black box, which is the flow file processor, again, it's basically transformer, filter, whatever it is you want it to be. So that's where you receive the data, do some kind of processing, and send the data out. Bounded buffer, which is a connection, which is the queue, the channel where the data goes. So there's really no connectivity, no direct connectivity between one processor or another. I mean, there is basically a queue in between, and the handoff is always asynchronous. So that's part of the data flow paradigm, which creates, which also allows you, because of that, it also allows you to manage each and individual processor in isolation. So you can start, stop a particular processor without affecting another one that may be feeding this processor that you just stopped, because the data is going to be accumulated in the queue, and once you restarted it again, then it's going to start pulling data from the queue. And then we have scheduler and process group as a way of organizing something that organizing something into a group, basically. So the equivalent in Spring would be like having an application context within an application context, where a particular application context expresses certain functionality, and now you want to integrate it with another application context. So this is kind of where the similarity is. So it's kind of all about connectivity, and what I always like to do here is sort of assimilate it to a network OSI model. So if you look at kind of layers of OSI model and try to understand how does NiFi sit, if you look at it from that angle, then if you imagine that application layer within this model is enterprise integration patterns, then NiFi sits as a layer above that provides you that obviously provides the implementation of those and adds the data flow concepts on top of that. So as already mentioned, asynchronous processing, reliable process connectivity, and provenance are kind of the key concepts within a NiFi. So basic connectivity of the systems are no different than any other. So it's, like I said, it's a pipes and filters architecture. You have a pub sub model where you have producers that produce data, consumers that consume data. And obviously those consumers themselves could be producers because they may be producing some other data from the data that they just consumed. So And I already mentioned earlier, so the extension points that NiFi provides you with is the flow file processor, flow file comparator, reporting task, controller service, REST API, and native ports. So flow file processor is usually the component that you integrate with the most, because that's really where most of the work is happening. Controller services, they're like shared services. For example, JDBC connection pools, JMS message factories. Those are controller services that you can share between many different processors. And reporting tasks and other things are the things that allow you to kind of receive information from NiFi on a variety of things that are happening there. And finally, we got to the demo part. So before I go there, any questions? All right. So let me see if it's running. Yeah, it's running. So this is what So this is what NiFi UI looks like. So when you start NiFi and then hit the web page, that's what you're going to get. So what you see in front of you is kind of both the design tool and management and monitoring tool. So let's try to build a very simple data flow. And I'll start from very trivial things, just to primarily concentrate on showing some of the features of NiFi, and then we'll try to build something more functional, especially with Spring. So we have, especially for the purposes of demos and sometimes for the purposes of testing, so we have processors, but what we have, once you drag the processor, as you can see, we have a bunch of different processors here. And you can imagine, like, if you're familiar with Spring integration, you can imagine, just putting a namespace in the XML file and then say, I want to create a JMS adapter or MQP adapter or something like that. So, and what we have, which is kind of helpful for testing, is like a generate flow file, which is basically a processor that is obviously has no value in production, but it's good for testing, good for demonstration, and so on. So what this processor does, it has a configuration like any other processor, and you can configure a variety of things. In this case, I want to say I wanted to generate the files about 10 bytes long. I want them to be text files, and scheduling. Right now, it's going to generate them basically as quick as the loop runs, but I can actually change the schedule and say do it in intervals of 1 second, and obviously it's much better for the demos to do it that way than to overwhelm your log file. And that's pretty much it. But you can see there's still a red squiggly, and if I right click on it, there's no option to start this processor because there's still a problem with it. And again, as a tool, if you want to make a tool useful, you want to be able to help your users. So for example, if you hover over it, it will actually tell you that there is some problem and what the problem is. So in this case, it says that relationship success is invalid. So relationships are essentially ability to connect several processors together, because this processor is going to produce something, but where is it going to send it to? So this processor based on its implementation requires you to be connected to something else, basically some consumer. So in this case, we have another processor. I mean, you can take any one of them that's right here, but again, for the demo, we have log attribute, which is the processor that will receive the flow file and will log its attributes. So again, if you want to draw a parallel to something like Spring Integration, Spring XD, you'll receive a message and you print the headers of that message. So in this case, we don't call them headers, we call them attributes, but that's essentially what that is. So, and now I want to connect the two together. And so now it created a queue. This is where the flow files are going to go to, and this guy is going to be consuming it from that queue. So right now you can see the red exclamation point is gone, and I can start this processor, even though this one still shows me that there's a problem. And this one basically says that relationship success is invalid, but I don't want to, basically the same problem as the previous one, but in this particular case, I really don't want to keep dragging because, to another processor, because I simply want to say, well, this is the end of the line. So what we can do is go into configuration and say that auto-terminate relationship success, which means that basically once you send something to success, it's just going to drop that file, basically like writing to dev null at that point. So, and now there's no more red squigglies here, right? So now I can select all, and you can see I can start those processors at the same time from here, or I can actually go individually and say I'm going to start this processor, and now it's started. And you can see that I can probably zoom. So you can see that right now it's receiving messages on this queue, and but this one is not consuming it because we haven't really started it. So now you can see that this processor is essentially becoming like a microservices running within a NiFi environment. So each one performs a specific task, and without really caring about whether somebody is listening or not. And I can, for example, stop this one and start this one. Now all of a sudden it's consuming, and I can go back to my console where it is running, and you can see it prints out. Well, it printed out. I mean, I actually didn't set the scheduling for 1 second, so it just printed out everything as soon as it consumed it. So, but this is basically it logs. This is all that particular processor does. It logs the attributes of the file to the console. So, so that's kind of the basics of how do you work within NiFi. So now let's look at some of the internals. So when you right-click on the processor, you see a lot of the things here. And one that I wanted to show you is data provenance, which I've been talking a lot about. So for example, you can see that many different provenance events. So as many times it generated a flow file, it actually generates the create event. And oh, sorry. Data provenance. Forgot how to do it. And when you click on the little eye on the left corner, you can actually do a lot of interesting things here. So you can actually look at the attributes without even of the particular flow file. You can actually also look at, this is actually very interesting and especially very useful when it comes to this concept of a data flow, is that you can actually look at the content of the flow file and download it, right? So in other words, that flow file already went somewhere else, but if you want to know how this flow file looked like when this particular processor created it, you can actually look at the state of that flow file at the time when this processor was created. So when it comes to, if something went wrong down the line, you can actually resubmit from here. You can actually try to understand and identify what the problem may have been and modify the contents of the flow file and then resend it through the flow again. So, and if we go back to this guy, I can also show its provenance events. And you see there's different event. It's a drop event because when we send messages to success, we just say it auto-terminated relationship. So at this point of time, this is the end of the line for the flow file. At that point of time, you can see that those files were dropped and so on and so forth. And then there's other events like expire events. For example, if your processor is not capable to keep up with the incoming flow files, and you can set expiration, and those files are going to be expired. So never lost, never disappears, but they're going to expire, and you'll see the expire event, and then you can manage what you want to do with those files that expire. Okay, so that's pretty much what I wanted to show about NiFi sort of internal. So now let's start talking about Spring and why we actually provided Spring integration with Spring. Because for those of you, for example, who are familiar with Spring integration, Spring XD, and Spring other Spring technologies that are based on a pipes and filters architecture, you probably see a lot of some of the overlap here. Because, for example, if you look at something like Spring integration, you can say, okay, well, you have some generate flow file service activator, and then you have like attribute service activator or something like that, and you connect them through channels. So, like, when would I use one over another? And from that standpoint, there is definitely an overlap, and I don't really have a good argument to say, well, use this over that, because this is really not the time or the place to even talk about this. What I really want to talk about is the differences between a data flow and workflow orchestration, because this is really what I found as the most different between, for example, Spring Integration and NiFi. And to better understand what I mean by this, we had a client, and this is how this whole Spring Integration came about. We had a client that was trying to, they're a Spring shop, they're using a lot of Spring Integration, but they were also using NiFi, and they wanted to do a lot of things within NiFi because their user community liked the fact that you can, just drag and drop and manage and monitor right from a single central point of control. And the use case that they had was they wanted to receive the message from JMS. They wanted to communicate based on that message with the database and generate an ID and then continue with their data flow. The problem, though, that they had is that if one of these call to database fails or JMS call fails, they want to be able to roll back that as a transaction. And they wanted to utilize the conventional two-phase two-phase distributed transactions. When they tried to do that, it didn't really work within NiFi. The reason being is because, as I said before, each processor is an independent kind of a microservice, so to speak. So each runs within its own process, each runs within its own thread. So obviously the conventional way of maintaining distributed transactions between these two processors would be impossible, right? But when we started looking deeper into the problem, I realized, you know what? There are workflow concerns and there's a data flow concerns, because at some point of time they were talking about this as a limitation within NiFi, and I said, well, this is not really a limitation. We were never really targeting that particular use case because it falls outside of scope of data flow in general. So, what we suggested to them is that you can use Spring Integration to, as you did before, to address those types of concerns and then integrate that as a processor within NiFi. So essentially, you're using Spring frameworks to create a variety of complex services that you should be able to incorporate as processors within a NiFi. So it becomes more of a, so NiFi became more of a environment that would allow heterogeneous Spring applications to integrate with one another in a kind of a very cohesive way. So the way I did it is basically, we can probably delete this for now. So we have a Spring Context Processor, and the reason why it's called Spring Context Processor because it's actually, if you look at Spring, the fundamental of any Spring application is Spring Application Context, right? That's what encapsulates the entire application, right? What's in there is kind of irrelevant. That's entirely up to you as a developer. All I want to be able to do is to send data to Spring Application Context and for you to provide a uniform way of receiving that data. And if you want to send me data back, then I want to be able to provide that functionality as well. So thankfully, I don't know, was it, Gary, 2-3 years ago, you guys, I took Spring Messaging as a separate module out of Spring Integration. So what I did is basically created a processor where all you need to do is define application context, and there's only a very small contract that I ask you to follow, which is define an input channel, define an output channel. How you connect to input channel or how do you send message to output channel is outside of what I really care about. All I care about is that this application context will have that input channel, will have that output channel, and then you're free to do anything you want within the Spring application context. So, and obviously it could be as simple as just echo, go back and forth, or it could be as complex as a full-blown application written using Spring Integration or written using some custom code. Again, it's entirely up to you. So, so to demonstrate how this works, here's kind of my sample, couple of sample applications. So I have this SI demo project, and we'll start from very simple configuration. I'm going to use Spring Integration for this. So it's basically going to receive data from NiFi, and it's going to log the data receive only service. So it's going to log this data to the console, right? And what the processor does internally, it converts the flow file to a Spring message, but by basically taking the contents and making it a payload, taking attributes, making it headers. So now you're receiving everything that you need. So the way it's going to work is this. So another problem with this approach actually is that, all right, I can point to Spring Application Context and you're going to bootstrap it, but the class path of that application context, I mean, obviously it's not just Spring, you're going to use a lot of other things that are specific to this application context. So when you look at Spring Context Processor configuration, at this point of time, there's not a whole lot to configure. There's only two required attributes. One is context configuration path, and one is context configuration class path. So if we look here, I've generated class path, basically through a little Maven plugin. And this is all that this particular application requires, right? So I'm just going to take this directory. And here's my class path, and a configuration that we're going to use is from NiFi only, from NiFi, right, from NiFi only .xml. Right, that's it. So we're actually ready to start this process. Let me just change the this to 1 second just to make sure it's demo friendly. Now, it's still complaining that I have problems here. So again, the same, very similar thing. This is one of the most common configuration message that you will see is that some of your relationships are not defined. Now, as you already see, I can actually, those relationship means that I have to send data somewhere. And in this case, you can either send it to another processor or you can auto-terminate them. So I'll just do this another one, log attribute, and I'm going to drag, and right now it's asking me which relationship. Basically, the paradigm here is that any kind of process can either succeed or fail, right? There may be other states, but majority of them will have the success or failure state, right? So I'm going to say, relationship, I'm sorry. So I'm going to say that send the data, send success, if processing was successful, send the data to the success relationship, and that essentially maps to this log attribute. I can actually cut and paste and say that now for the, for the failure, send it here, and I'm actually going to rename it and say this is fail. Success. So now if something went wrong, it's going to go to this one. If something went right, it's going to go here, right? So at this point of time, I can actually start this processor.
Where does this processor get its data from?
I'll get there in a second. So as you can see, that's actually a very relevant question, especially the way I configured this, because you can see that the processor is running, right? Everything is good, but there's no data coming in, right? So because I said from NiFi only, so it's sitting, listening on the channel, but nothing's coming in, right? But the reason why the processor is running successful and the reason why it does not require the input, because the Spring Context Processor operates in 3 modes. Request, reply, receive as a consumer, as a producer, or as a consumer and producer. So you can do request, reply, you can do request, you can receive data, or you can send data, right? So in this particular case, for example, if I have a configuration, which I'll show you in a second, if I have a configuration where you want to, Spring becomes the source of data, and it's going to produce the data to be sent into the NiFi, then you will start the processor, and it would get the source of data from there, okay? So what I'm going to do right now, Because for this particular demo, I can do things. I can either bring that generate flow file, or actually I have that Twitter adapter here somewhere. I don't know where to go. And I can generate data from there, or I can actually change my configuration to use different application context configuration. And this is actually what I'm going to do, because this makes it more interesting for the demo. So imagine what just happened. When I started the Spring context processor, it created an instance of Spring Application Context, obviously loading all the classes that it requires and so on and so forth, right? So now when I stop the processor, it stopped the Spring Application Context. But the problem is that all the classes were already loaded, right? And given the fact that everything is running within the same JVM, we have a bit of a class loading issue there in case if I want to change some code, or even worse, if I want to create another instance of a Spring Application Context processor and run on a different version of Spring. So there's a little bit of a class load trickery that I've done that allows you to reload all this upon the restart of the processor. So you can basically run multiple instances of a variety of different applications. And in this particular case, if you want to change something like through configuration, or you want to change something within Spring configuration, you don't have to rebuild and redeploy. You simply change it and restart the processor, and it's going to reload everything the way you expect it to be. So in this particular case, I'm going to go back to configuration, and I'm going to go not from NiFi only. I believe I have another one. It's called to NiFi only. So instead of from, we're going to do to NiFi only, right? So to NiFi only, let's look at the configuration. This one points to send only service. And this one is basically started as a Spring lifecycle bean, and it simply generates the data. So in this particular case, if I start this processor right now, you'll see it starts receiving data, because now there's no data coming into, but there's data coming out of a Spring application. So imagine you have a Spring Application Context with, I don't know, some adapter pointing to external system. That system produces the data, and you're bringing it into the NiFi. So it's a good use case to see what's going on here. So I'm going to stop it. And now I can obviously, right now I have a bunch of messages accumulated in the queue. I can obviously start this processor and flush them out. Or I can also do, like, again, if I don't really care about this data, I can simply go and say empty the queue. At this point of time, I'm just going to empty out the queue. And right now, you don't have any messages, and so on and so forth. So just to show you again a different way of interacting with this, we're going to change it to request reply. Yeah. Actually, let's do a more interesting one. I have a bidirectional. So what this one does, let's look at it. So it's bidirectional with aggregation. So essentially, what it will do, it will receive the data, it will aggregate it. In this case, basically batches of 8. And then it's going to output them. So technically, what we should expect to see here is that once we receive the data, for each 8 flow files, it should produce one message and kind of aggregate the data. Yes?
If you could just make it a little larger.
Yeah, I'm sorry.
Thank you.
Better? So in this case, I'm going to create this generate flow file. Hang on one second, I want to do something. I had I deleted it, okay. I pre-created a Twitter adapter to make it a little more interesting, but the reason why I pre-created it because I wanted to copy all the keys, secret keys, and whatever, so I'm not going to do it right now because for obvious reasons, but we're just going to use generate flow file to generate some data. So configure. Let's just do 10 bytes. Some gibberish text. So now we're going to say this is going to be a producer for this component. So, we're good. Let me change the configuration scheduling to 1 second. And by the way, since we're in this pane, you can see we have a variety of scheduling options. You can do timer-driven, or you can do cron-based, and so on. Yes?
How is this different from Apache Camel? NiFi is actually kind of a UI-based thing.
So let me repeat the question and make sure I understand it. So the difference between Apache Camel, right? You're asking about the difference between Apache Camel and NiFi, or the difference between Apache Camel and Spring Integration?
On the
NiFi. So Apache Camel is another implementation of enterprise integration patterns. Okay, so again, it's all about pipes and filters and enterprise integration patterns, not about the data flow. It's a developer framework similar to Spring Integration, and you can build using Camel, using Spring Integration, or using a variety of other frameworks. You can build data flow products, right? Because, like I said, the key concepts here are, it's not just ability to connect two processors together, because those are pure pipes and filters concerns, right? But when it comes to provenance, lineage, and history and everything else, to be exposed as first-class citizens, you can of course do all that using Spring Integration or Apache Camel, but you have to build all that, right? Where here, you simply created two processors, and all that other stuff that is specific to the data flow was given to you out of the box. Does that answer the question?
Yeah.
So, and again, this is a kind of a very delicate part, because it is, you're absolutely correct, there is an overlap when it comes to a variety of functionality. So in this particular case, I'm just getting the data, putting the data, and there's a channel in between. Yes, there is, that concern falls directly into the category of enterprise integration patterns. However, when it comes to all the other things that you saw, like the data provenance and lineage and other things, those things would have to be built in. And for example, in Spring Integration, yeah, there is a message history implementation, which means you can build all that, but you have to, as a developer, know and put everything, basically assemble your application context to put everything to enable that, right? And on top of that, you would have to worry about which runtime environment I'm going to run it, how I'm going to monitor it, and everything else. So all those concerns, while possible to be addressed within frameworks like Camel and Spring Integration, you as a developer would have to do. Here, they're already provided you by the product. So that's the difference between a data flow and as a product versus workflow orchestration frameworks like Camel or Spring Integration. So, all right. So I'm going to basically, in this case, I'm going to start all processors at once. Actually, I can't do that because I still have problems here, so I'm going to basically auto-terminate this. And I'm going to auto-terminate this. And right now I have a healthy flow. I can select all, I can start, and see what happens. All right, so actually, let me just stop it, because it pulls thing from the queue so quickly we didn't even see that for each 8 messages there was a flow file generated here, right? So right now I stopped it. So now you can see that we have 30 files that came in, but we have only 3 files that were outputted, because we're using, it delegates to Spring, Spring aggregates everything, sends the reply back to Apache NiFi, and it produces a flow file with aggregated contents of whatever was sent, right? So that kind of demonstrates this ability to integrate Apache NiFi with Spring-based application. And obviously, when you look at this application context, you can, I mean, it's very simple right now, but you can imagine that you can build extremely complex application, and all you need to do is take care of defining a from NiFi channel as the, you can define it as any other channel, and to NiFi should be a pollable channel. That's kind of a contract requirement, and it's all part of documentation. So, because our processor has to be able to poll for the data and react when the data is there and do nothing when the data is not there. You got a question?
I have a question. Is it only way to provide Spring actual context through XML file, or you support as well Java configuration and
Okay, so the question is the only way to provide integration with Spring application context via XML application context, or do we support annotation, configuration, Java-based Java? Yeah. So at this point, the answer is yes. Right now, it is the only way. But what you can do right now, don't look at this as a limitation, because I kind of almost deliberately did that, because look at this as more like you have application context, right? And it's XML, but what you can, instead of defining components inside of XML, you can bootstrap your Java config or annotation-based configuration within this XML. So you can just point to that by defining it as a child application context. So now this XML basically serves as a container to host variety of application contexts, however you decide to create them, right? So does that answer the question? Yeah. So you can do that. As project progresses and as we get more usage and if we get more requirements to expose that as a first-class citizen, we will do that. But right now I didn't feel the need to do that, especially that it doesn't preclude you from doing exactly what you wanted to do. The only inconvenience is that you have to define it as a child application context within this particular XML, right? So yes?
Not sure if you're going to cover this, but anything specific to debugging these kind of flows, whenever the flows are configured in XML files, right?
No, you're talking about flow is like a Spring flows, Spring configuration, Spring integration?
Spring integration or camel integration, right?
Yeah.
So when we do that, we need to write specialized test cases that also take into consideration those. It's not your normal test case, right? Is all I'm trying to say.
Right. So I guess let me try to paraphrase the question and see if I get it right. So the question was about debugging and testing when it comes to, well, so if I understand the question correctly, then here's how I'm going to answer it. Spring application context is an SLAted application, which means you can, and one of the beauty of Spring is that while this provides you the way of running this application context within NiFi, you don't need NiFi to test the functionality of what's in Spring application context. So I would expect you as a developer to do diligence and test everything before you deploy it to NiFi, right? So at that point of time, you know, everything basically supposed to work. And for me, the application context just simply becomes a black box. Now, if I develop a processor within NiFi, developed from scratch writing Java code, then of course I would go through the same type of rigorous testing to test the functionality within that processor, right? So, but in this case, and right now, they're both processors. One is written using Spring application context, another one is written pure Java code. You're doing testing the same way you would normally do, right? So. And then debugging of that particular part, yeah, we have debugging options within NiFi and a variety of tracing options and reporting tasks and so on and so forth, which I won't be able to cover right today. But for this particular case, for your particular question, this is what I would expect, for example, for a developer to do. So what was I going to say? Okay, so another thing I was going to show you is that what I was telling you earlier about this dynamic ability to reload classes, reload your application context. So in this particular case, what I'm going to do, I'm just going to change this to, let's say, aggregated by 2. And then all I need to do here is stop and then start again. And right now it's going to be aggregating by 2 as opposed to, you can see it's now putting data much quicker because it's aggregating. All right, so you don't really have to, and you can have multiple application contexts, and you can have, within a single instance of NiFi, you can actually run multiple versions of Spring as well. So there's a class path isolation and class loader isolation. Yes?
So those queues are block queues or what kind of queues are?
I didn't quite catch that.
The queues, the success queues.
Yes.
So that if we use processor, right?
Yeah.
Failure and on the Spring context processor, there are queues in between. So those queues are block queues or what kind of queues?
So, well, okay, so if you look at, you're asking about these queues, or, so these are queues, just regular queues. In this case, the implementation behind it is the blocking queue. So there's no magic there. The messages are, because everything is asynchronous, there's no direct dependency. There's no, for example, like there's no concept of a direct channel that you have in Spring integration, because there's always a thread boundary in between the two, and that's what allows us to stop or even remove the producer, change the consumer. I'm sorry, consumer, and because the message is still going to be stored on the queue. Okay. I'm sorry. Yeah. So there's a configurations. Yeah, you can. There's also a concept of a backpressure where at some point of time, if queue accumulates a certain amount of data, the scheduler that's going to be disposing messages from the queue is going to kind of slow things down to make sure that you don't overwhelm your system and so on. So, all right. So we're almost close to the end. Any more questions? Yes. Yes, yes. So the UI, so it's one of the things that we're doing for 1.0 release. So the UI, we have a pretty decent sized UI team. They're making it more kind of crisp and so on. So yeah, this is a version 1.0 snapshot. So I know that the version 0.7, that's the latest release, looks a little different. So yeah, this is what it looks like, what it's going to look like in 1.0. There's still some UI work going on, so there's going to be some minor changes maybe, but that's pretty much. Well, we are in the process of, like right now, like when I'm not on stage and not drinking, I'm reviewing PRs. So basically it's imminent pretty much within week 2. So it's going to happen in August. Before we go, I want to show you something else. In other words, so just to summarize, this processor allows you to integrate your existing Spring application within NiFi. I don't even want to say Spring integration application because, like I said, I don't really care how you implement communications between those two channels. Between these two channels, you can simply use API and say just pull the message or send the message, and that's it. So what I would actually, the more correct way would be saying that it's integration with Spring messaging module. Right, and at that point of time, what you're going to do inside here, it becomes a black box for us. Now, aside from that, NiFi also uses Spring internally. So and pretty much web layer uses Spring MVC, okay? But we also use Spring when we develop some new processors. And there's a processor that I was asked to develop to do the IMAP and POP3 consumption of emails, right? Well, interestingly enough, 5-6 years ago, I was writing, modifying, rewriting majority of the code for that particular domain within Spring integration. So I said to my people, I said, I really don't want to go through this thing again. I already written this code. Can I just use Spring integration as a library? And here's what I was going to show you. So, for example, here's a processor called Consume POP3. Here's a processor called Consume IMAP. And all I'm doing here is basically using POP3 mail receiver and IMAP mail receiver. And from that point on, I know that that code has been in production for a number of years. It's obviously tested. And if there's any bugs, I have these two guys to fix them for me. So it kind of becomes a win-win situation for all of us. Right, so and that's kind of the end of it. This is what we how we integrate and use Spring within NiFi. So just to summarize everything, NiFi is a data flow product and a framework. Things like Spring integration and Spring provides developer-oriented frameworks. There's some overlap in some of the functionality. But I hope you saw that there's obviously a certain amount of features that are specific to data flow. They're not exposed as a first-class citizen within specific Spring technologies that you would find somewhat comparable to Apache NiFi. And while you can build that functionality, you may find usage of NiFi and Spring together interesting, because in my opinion, in my honest opinion, they're not really competing type of technologies. They're rather complementing technology because I can now look at NiFi as my data flow modeling, management, configuration, design tool, and look at my variety of things that I want to do with the data as sort of mini microservices, mini applications that are implemented, for example, using Spring. And I can use NiFi to join everything together into one cohesive data flow. Yes?
Curious how you deploy one of these in the real world. I get what you're deploying locally, all in the same JVM. Like, what if you need to scale a processor, one steps out horizontally?
Okay, so
Beyond like a single JVM, like what does that look like?
So the question is about what is a typical production deployment and how do we scale. So obviously what I'm running right now is a single node instance of Apache NiFi. We have a cluster. That's what you typically do. So that's what typically runs in production. So we have a cluster environment, so you can start it as many nodes as you want, partition them based on the physical, virtual, whatever. So, and now you have multiple nodes with multiple instances of that processor running. And obviously, another thing worth mentioning is, again, going back to UI and looking at the configuration. So scheduling, you saw, so run schedule, right? So I'm saying it's going to run every second. But what I can also do to address the scalability concerns, you can see by default it falls into a single concurrent task, right? Basically single threaded. But I can define multiple concurrent tasks and address the scalability this way. So now picture this, and on top of cluster, you can achieve pretty good scalability results.
Is the size of the cluster, like its capacity exposed up through this UI, right?
Yeah. So the question is, once you're running in a cluster, and I don't have time, but once you're running in a cluster, you will get, for example, we call it hamburger menu right here, but like right now you see whatever the options that you see. But if I were to be running it as a cluster, right, you would see another couple of extra options there, and you'd be able to actually, it becomes also a management and monitoring tool for your cluster. So you can actually connect nodes, disconnect node, perform maintenance and management and so on and so forth. So again, that's yet another value that NiFi provides, because it is to give you the view into your entire cluster and see what's going on. Any more questions? Well, guys, I'll be hanging around there, but thank you very much for attending, and I hope you enjoy the rest of your Spring One.